Hello, my name is Itai, and today I'm going to be talking about the use of artificial intelligence to automate the generation of comments and summaries for code. So first of all, what is code automation in general? Software development is a rapidly growing field, and a lot of programmers, because they're technical, utilize AI, and a lot of the time that programmers have to spend, up to 90% according to some sources, is dealing with existing code that they are unfamiliar with, either using an existing code and updating it and adding features to reduce the overall work, or you often want to use publicly available libraries. In both of these situations, there is code that is already written by someone else that you have to now work with and understand how it works. You might also want to take an existing code and convert it into a new language. No matter what you do, but the moment that there is code that already exists, you first have to understand it. To that extent, why do you want to write comments? Because you have to work with unfamiliar code. Having something that says, this is what the code does, this is why it works this way, can help you a lot. And because programmers are trying to automate writing the code, there are also attempts to automate this phase. And just like the rest of the field of AI, this subset is so rapidly developing. Existing literature reviews are to some extent old, and therefore need to be updated. And this review builds on the existing corpus and updates with the new state of the art. So initially, I used IEEE Explore, Google Scholar, and Engineering Village, with keywords like documentation generation, software development, artificial intelligence. Using those, I have found 5 original research articles as well as 1 literature review. I then looked at the citations to find recent articles that were related to the topic. From this, I had 20 articles, so I then looked at their abstracts to ensure that they are relevant, as well as to ensure that the article is credible, so it was published in a peer-reviewed journal. I have also used ChatGPT in order to give an estimate of how high quality the writing is, and from that I reached the 5 final articles. So the results. The first article I'll be discussing today is by Rai. It's a review on source code documentation. So they have found that originally in the field, programmers either used manual templates and then had artificial intelligence fill those templates, or they found a similar piece of code in their database that already had comments and then used those comments as a basis for the new comments. Both of those methods are highly sensitive to the training data that there is access to, and therefore worse. They also tended to require initial human work before starting. The more modern approaches use deep learning, and the more traditional artificial intelligence, they generate the comments in a more direct fashion, and they've led to a very big jump. The approaches was even further boosted by including the structural information of the code. So because code is highly hierarchical and highly structural, passing that information on to the comment generation in some way has been shown to boost performance. They've also noted a shift in how researchers evaluate their results. The initial approaches were completely manual, so humans read the code, compared it with the comments, and said, how good is this? Nowadays, the researchers use metrics that were developed for the machine translation field. So essentially they consider 2 languages. Well, one of them is the raw code and one of them is the comment, and they see how well does the code translate. Also, researchers primarily worked on Java and Python, and the data mostly came from GitHub and from Stack Overflow. Another question was, what do we put the comment on? So you can have a comment either describe an entire file or just a section of it or a single method, and generally people write comments for a single method at a time. And a quote that really explains the article's argument in their own words: source code generation has gained a lot of attention from the research community in the past 5 years, primarily summary generation. So as I said, there is a lot of focus on it, primarily in the past 5 years from when the article was written, which coincided with the rise of artificial intelligence in general, and most researchers focus on writing a brief summary for the entire method at a time. The next article is by Chen, Why My Code Summarization Model Does Not Work. So the article identifies that comments serve different purposes, and they put them in 6 categories. So the first category is what they call what. So these comments describe what does the method do overall, what is the overall behavior of of it. Why explain the rationale behind the method? Why was it written this way? Why does it even exist? How to use, as the name says, explains how you can interact with it. So for instance, this is the parameters that I take, this is the reasonable values for them. How it is done explains more the behind the scenes of how the method actually works. Property explains various artifacts, so for instance, it might explain a single parameter of the method, and there is also the other. The way they train data to do it is they first take a small database and manually say, okay, this comment is this category, and then they test a few publicly available comment generators and look how they behave. What they found is that for every model there was some category where it was the best, and also each category has its best model. So there's no single model that is the best in every category, and there's no category where every model is the best compared to itself. Because of that, they see when we should have each model write a comment based on when it's the best. So they first identify what category might be appropriate for this piece of code, and they then choose the appropriate model and have that model generate the comment. They then look at a few different ways to classify what is the type of the comment, and what they found is that the more accurate the classifier was when compared to the manual classification, the better the overall method was. And as long as the classifier was good enough, it was an overall improvement compared to the individual model. Because of that, they recommend that future research really goes into let's generate a model for this specific type of comment, and then combine that with a selector that really goes, this is the best model for this application. Additionally, they found that models really struggle with the why category because it includes information that isn't in the code. And the quote that shows their argument, the preferences of each model to a particular comment category are different. So as I said, each model has a different category where it's the best. Motivated by this finding, we design a composite two-step approach that analyzes a method and outputs a comment that summarizes it, so which type is the best and which model is the best for this type. Our approach predicts the category of code comment that likely accompanies a particular piece of code. Our approach then picks the code summarization approach that performs the best for the inferred category and use it to generate a corresponding comment, passing it off to the best model. The next article is from one reinforcement learning guided source code summarization using hierarchical attention. The article identifies two types of information that models use, either structured, so information relating to how the pieces connect, and non-structured, so essentially the plain text of the code. They then use a hierarchical attention network to identify how important is this individual token and how does this token fit in. Tokens form statements and then statements form functions. They found that this approach is an improvement over the current state of the art, and a quote that summarizes their position, this paper presents the first hierarchical attention-based learning approach by utilizing unstructured and structured features of code to reflect the hierarchical structure of code by supporting a two-layer attention network at both token level and state level, noticing the hierarchy and using that to determine how important is a specific token for the comment. The next paper is from Gao, Code Structure Guided Transformer for Source Code Summarization. They use the transformer approach, which is widely accepted, but restructure it in a way that it uses the structural information because research has shown that it's useful. So instead of having the code select what is important purely based on the data, it first gets the structural information and uses that to pay attention to the different tokens or pay importance to the different tokens. They feed it with both the local and the global structure of the code, and they found that it is an improvement compared to other models, primarily because it can identify the relations between the different pieces of code, and it can also identify the important tokens better. So it can go, this token is really important and therefore it should be included verbatim in the comment. And the quote that shows their argument is we extract the pairwise relations between code tokens based on the local symbolic structure, such as code token state and statements, and the global structure, that is the data flow graph, how does the data go from one place to the next, and then inject them into the multi-head attention mechanism as inductive bias. The way transformers work is they decide how important different tokens is, which is called attention, and they give it a bias, so they start off with this approach, which is based on the structure. The next paper is from Yang, Doc Agent, a multi-agent system for automated code documentation generation. They identify three main issues. The first is context identification and retrieval, figuring out what is the wider situation around the code and getting the needed information. Navigating complex dependencies, so often one file takes information from another, and if you have a very long chain of this needs that, it can be really problematic. And robust and scalable evaluations, evaluating the result automatically as you generate. So what they do is they have a few agents and an orchestrator that moves between them. The first one is the navigator, which determines what is the best order for the orchestrator to move pieces, which addresses issue number 2. And essentially it has it start from the thing that everything depends on. Then there is a reader searcher loop, which gives the context and fixes issue number 1. So they start with a reader that looks at a different code and goes, okay, this is the information we might need. And then it goes to the searcher, which goes and gets that information. And then the reader might go, okay, we need this information now, or say we have enough. Then the writer generates the actual comments, and the verifier solves issue 3 by checking the output, and it can then either move the info back into the writer, or it might go back to the reader searcher. So a quote that summarizes their position: we introduced Doc Agent, a novel tool-integrated multi-agent system that leverages a dependency-aware topological processing order determined by a navigator module. This allows specialized agents to collaboratively generate documentation. So now I will move on to discussing the result. The current research can generate pretty good comments, and there are various different approaches for how to do it. Pretty much everyone uses this structural information. Gao just adds it to another underlying implementation. Researchers focus on Java or Python code that they get from the internet, and they evaluate the results as if it's a translation. However, there is no single metric that everyone uses, and also everyone uses a different database. However, the overall contributions could be combined because each paper explores widely different approaches, and none of them are really mutually exclusive. We could have a model which takes the underlying approach of one, but adds info from another. Now, an overall conclusion of my literature review. In general, programmers spend a lot of time with existing code, and therefore they need comments in order to be able to understand the code better and not have to completely read the new code every time. There are various approaches that different papers use. Almost everyone includes the structural information. Generally, researchers evaluate it as if it's a translation, and the approaches can still be integrated, which I might do in a single thesis. So one could create a model which is based on Doc Agent, but also uses the hierarchical attention and also uses the comment type. And there is a room for better metrics to evaluate it, or better databases that can be standardized. Thank you very much for listening.